Hi, my name is Jill Deines, and I'm a postdoc with Stanford Center for Food Security and the Environment, as well as NASA's Harvest program. And my talk is called Subfield Yield Estimation with Satellites. How good is it, and what can we learn? My full talk will have an evaluation of satellite yield estimates using a ground truth data set of over 1 million fields in the US Corn Belt. But for this short version, I want to focus on the second part, what can we learn, specifically about the yield impacts of conservation tillage. So the problem is that the world's farmlands have incredibly high rates of erosion and soil degradation, erosion often on par as the same rate as mountain terrain. Over the last few decades, conservation agriculture has emerged as a solution to kind of combat this, where basically farmers are keeping more residues on the field and disturbing the soil less in order to reduce erosion and promote soil health. But there's still kind of a question, particularly with tillage, of how that affects crop yields. And because soil degradation happens over very long time scales, this near-term yield impact is really important for farmer adoption. With satellites, we can look across thousands of fields at the same time. My lab group has developed annual map data sets of both tillage type and annual crop yields. Here we're looking particularly at maize in the US Corn Belt using Google Earth Engine. And here I don't want to focus so much on data set production as the challenge of kind of how do you do causal inference when you mash up two observational data sets. And so, of course, kind of the key thing here is that this wouldn't be a randomized trial. We have no control over which fields do tillage or which fields do no tillage. And so if kind of just by chance you have fields that typically have higher or lower yields, adopting tillage at different rates, you kind of have a bit of bias in the analysis. So we address this in two main ways. First, we just kind of clean up the input data in smart ways, doing data set filtering, basically just to increase confidence that we're using the best pixels and the best classifications that we can. And then we use the method called causal forest, which is basically a random forest that's adapted for causal inference. And so the key thing here is it's kind of matching up fields and comparing fields that have similar attributes. So what we find is that on average, reduced tillage improves maize yields about 3.3% across the region. And as you can see in this figure here, there's a whole range of outcomes. So there are some areas where it decreases yields. Typically increases them in some places that effect is stronger than others. And so in the full paper, we kind of relate this to underlying variation in soil and climate. But overall, our work here supports soil conservation efforts by demonstrating that they can be used with minimal and typically positive yield impacts. And so the link here at the bottom has the paper that describes the tillage analysis that I've talked about. And if you particularly are more interested in the satellite yield estimates and want to dive deeper into that, check out the full length talk.